Notes 4.4 continued. We're going to solve more exponential equations algebraically, and then we're going to round our result to 3 decimal places. One of the strategies was to get the same base so we could set the exponents equal. However, you can't write 8 and 360 with the same base. They're not both powers of the same base. So the other strategy is, let's get the exponent x out of the exponent position by changing to a log form. So 3x equals log base 8 of 360. At this point, you can find that value on your calculator, divide by 3, and you're done. Let's go ahead and do all the calculations and do the keystrokes at the end. So divide both sides by 3. All calculator work, build your fraction first. In the numerator of your fraction, do alpha window, option 5, fill your denominator in. Okay, and it says round your result to 3 decimal places. 0.944. At least for this one, please stop the video and make sure that you're able to do the keystrokes that get the answer of 0.944. Five is raised to the fraction negative t divided by 2. That's equal to 0.20. 0.20. All right, the strategy of getting the same base is out, so let's change it to the log form. At this point, you can find that value on your calculator and then continue solving. I'm not going to find the value just yet on the calculator. I'm going to wait till the end. Algebraically, to get t by itself, I need to multiply both sides by 2. And I'm going to multiply over here by 2. The 2's cancel, leaving me negative t equals, I'll put the 2 up front so I won't get confused and multiply these two together, which is not allowed. Oh, come back, L. I'll divide both sides by negative 1. To get the result, just go straight to the calculator, enter all this information. I don't need to round because my answer is actually the whole number t equals 2. All right, we need to solve for x. We're going to change it to the log form, but we can't change it to the log form until we isolate the power. All right, so let's go ahead and divide both sides by 250. Doing this division on the calculator should result in 40. Now we can change to the log form. Log base E of 40. Remember, log base E could be rewritten as ln of 40. That'll save you some keystrokes on the calculator. Divide both sides by 0.02. The result is 184.444. Continuing our work solving exponentials. Yeah, not ready for equals yet. It's minus 13 equals 100. All right, we want to change to the log form, but we have to isolate the exponential piece of this first. So let's add 13 and then divide by 5, and then I can proceed by changing the form. So we're going to add 13, so this becomes 113. Sometimes you'll see the 3 minus x on the outside. Sometimes you'll see the 3 minus x on the inside. That doesn't matter. You can still see that 2 has a power of 3 minus x, regardless whether it's written this way or this way. Add 13 gives 113. I'm going to divide by 5. I can't change it to log form until I isolate the exponential piece. So if I divide both sides by 5, that leaves 2 to the 3 minus x power, 3 minus x, equals 113 divided by 5. I'm not going to find that value just yet. I'm going to change the form. So go to the exponent. 3 minus x equals log base 2 of the fraction 113 divided by 5. All right, at this point you can find this value if you want and then dump that value in here and then continue solving. Otherwise, I know that I'm going to subtract a 3 from both sides. So I'll put the minus 3 here. So subtracted 3 from both sides. And then, of course, I'm going to have to multiply everything by -1. Or divide by -1. So that changes the signs of all your expressions here. And then the plus 3. You have to distribute that negative through the other side. So now you can just do all this entry into the calculator to come up with an answer. And the result was -1 point, or decimal, 498. Decide if you want to wait to the end to do all your calculator work, or if you'd like to just do the calculator work early and bring the decimals down throughout. Okay, there's just advantages and disadvantages of both those methods. Okay. All right, we have 2 more examples here, and they change slightly. I'm going to go ahead and get both the examples in front of us and then go back and solve them. Notice that in both of these examples right here, we have an exponential, an e base on both sides of the equation, and we only have one, meaning only one exponential on each side of the equation. And there's nothing else besides those one exponential terms on each side of the equation. So the method I'm about to take here can be used because I have an exponential on each side of the equation with nothing else, meaning there's not a +7 here or -5 or anything like that. So on both 5 and 6, what I can do is I can see that the bases are equal. And in our previous work, if the bases are equal, the exponents have to be equal. That's the approach I'm going to take. So x must equal this exponent of x squared minus 2. We have to continue and solve. So now we're to a quadratic. And thinking about our previous work with quadratics, I would probably want to solve one side for 0. So let's subtract an x from both sides of the equation. I don't want to bring x squared over to the other side because it becomes negative, and I don't want to work with a negative x squared term. So go ahead and bring x to this right side, and then we can trade sides. So I'm going to have x squared, bring over x, minus x fits in here, and then record the minus 2. Okay, if you're uncomfortable with 0 being on the left, we'll just trade sides. All right, how do we solve? Well, we factor. Or we use quadratic formula. I think this is factorable though. Factors of -2 that add to -1. This would have to be -2 and this would have to be +1. I think, yeah, that was supposed to be a negative. All right, looks like both of them are good solutions. I should have been checking all these solutions to see if any of them are extraneous, but it looks like if I took each of these x values one at a time and put them back in for x in the original problem, that they would both work. All right, example 6, same base, set the exponents equal. Let's do our algebraic work. The square term is on the left. It's positive. I'm going to leave it there. So I'm going to 0 out the right side. Okay, when I bring this over, it becomes a negative x to collect with -3x, which means -4x. And when I bring this 2 over, it becomes +2. And please don't forget your equal 0. Otherwise, you don't have an equation to solve. You just have an expression. All right, I know that's not factorable, so my other options for a quadratic equation would be to go to the quadratic formula. So my solutions are x equals... A is 1, B is -4, and C is 2. So opposite B, plus or minus square root of B squared minus 4AC. So B squared minus 4A is 1, C is 2. All over 2 times A, or 2 times 1. All right, the cleanup is 2 down here, 4 up here to lead off, plus minus square root of, let's take care of this value. This is going to be 16 right here minus 8. 16 minus 8 is 8. Still have some simplifying work to do. I've got some free space over here, so I'm going to clean this up a little bit. 8 can be rewritten as 4 times 2, so the square root of 4 comes out as 2, so radical 8 is really 2 radical 2. Okay, I can divide a 2 out from the 4, I can divide a 2 out from the 2, and divide a 2 out from itself down here. Now, if this 2 wasn't there, if it was just radical 2 with no coefficient, I couldn't simplify any further. 2 divides out here 1, leave a 1, leaves a 2, leaves a 1 there. I don't need a fraction anymore because 1's in the denominator. So the final solutions would be 2 plus radical 2, comma, the other solution would be 2 minus radical 2. All right, so we were continuing our work solving exponential equations, but it seemed like the overall strategy was to change to a log form until you got to 5 and 6, where the basis just dropped out. We'll continue in the next video.